Right, in exercise 8.8, it's titled the composite function rule. I've always thought of this as the function of a function rule. It's got a couple of 2 or 3 different titles or ways of describing it. And I'll probably refer to it as the function of a function rule. It's the way I was taught, and it also, for me, makes more sense. I'm not going to go through the theory of this, but I will demonstrate what we need to do when trying to differentiate functions of this type. What I need you to be able to see is that we have an overall description here. We've got to find the derivative of this expression 3x minus 1 to the power of a half. And with that expression 3x minus 1 to the power of a half, what I hope to draw to your attention is that what's inside the brackets is actually a function of x. That's one function of x. But then what's outside the brackets is also, you could consider it to be a function of x as well. So there's 2 functions of x that are at work there, which is why it makes sense to me to call it the function of a function rule. So the way that we go about finding the derivative of this expression with respect to x is, first of all, I start with the part of the function that is inside the bracket, so that's this part here. We work with that and we find out the derivative of that part of the function. Really what we're doing is we're finding the derivative of 3x minus 1, and the derivative of 3x minus 1 is going to be 3. Then what we do is we find the derivative of the secondary part of this function, which is the outer box that I've just highlighted there. And if I were to think of that in terms of finding a derivative, we bring this to the power of a half down to the front of the function. So we'll have a half there. Now the bit that was in the brackets actually remains just exactly as it was, but as we have done previously in finding derivatives, this to the power of a half, we've got to subtract 1 from that power of a half, so we end up with minus a half. And really that's it. That's the derivative. What you might find in the answers in the textbook is that they rewrite this in a form which has exactly the same mathematical meaning. It's just written in a different form, and it could be written as 3 over 2 times the square root of 3x minus 1. And I'll let you look at how we get from this line here down to this line here. That's something for you to discern. Question 1, part O, same thing as before. What we need to do is look at this expression and see that there's a function of x that's inside this brackets here. There's one function of x there, and then there's all of that expression raised to power of 3/4, and we need to think of those as 2 functions of x. So to find the derivative of this expression with respect to x, let's differentiate what's inside the brackets first of all, and the derivative of that part of the expression will give us 3x squared minus 14x plus 1. And now we bring down this part of the expression to the front, so we'll end up having times 3/4, and then we multiply the original function, which is x cubed minus 7x squared plus x, and we subtract 1 off the power of 3/4, and when we subtract 1 off the power of 3/4, we'll end up with minus 1/4, and that could finally be written in this form: 3 outside of 3x squared minus 14x plus 1 all over 4 times the 4th root of x cubed minus 7x plus x. Alright, with question 1q, we've got to find the derivative of 1 over 5x minus 2 with respect to x. First thing I need to do is get that denominator so that we've got it in index form. And in index form, it'll be the derivative of 5x minus 2 to the power of minus 1 with respect to x. So again, let's differentiate what's inside the brackets first. Gives us a result of 5. We bring down the power that's outside of the brackets, which will give us minus 1, multiply what's inside the brackets by what was there originally, and then take off 1 from the power of minus 1, which will leave us with minus 2 there, and in its final form, that will give us minus 5 over 5x minus 2 all squared. It's 1q. Right, for question 1u, we're finding the derivative of this expression here. Again, first step is let's get it into index form. Hopefully by now you're starting to see why indices and the index laws are so important to understand, so that we can convert from notation that has the radical signs or the square root signs and convert that into notation that's going to be using an index form. Now that half that's out the front, that's a constant term, so that won't interfere with anything. In fact, you could even rewrite this as a half times the derivative with respect to x of 3x minus 1 to the power of minus a half. Those two expressions are equivalent there. And now we perform the derivatives as we did before, the function of a function rule. So we'll have a half times 3 times minus a half. That minus a half has come from this power here being brought down to the front. That's where the minus a half, this minus a half here comes from. Times what was inside the brackets, and then you subtract 1 off the power, which gives us this minus 3 on 2 here. And that can be neatly written in the end as minus 3 over 4 times the square root of 3x minus 1 cubed.